this video we're going to design a stair and output the manufacturing files. We'll also show you how easy it is to modify the project specifications. Detailed guidance on the design process is covered in our other resources. We already have all the required information for this project. We know the wood type, the stairwell dimensions, the well hole details and the floor-to-floor height of 2,800 millimeters. First, let's have a look at our CAD drawing. Here we can see a length for the first flight of 2,000 millimeters and a width of 900. The second flight turns to the right and has a length of 2,500 millimeters with the same width of 900. At the end of the flight, there is an exit angle of 15 degrees. Back now in StairDesigner, we click on the New Stair icon. A pop-up window opens. We can start from a predefined model, but in this case we will use the Multi-Flight Stair tab to create our stair. First we'll choose the manufacturing method shown here. These methods are pre-configured collections of construction preferences. They contain parameters such as the type of materials used and component presets such as thickness, exact positioning, and the assembly details between parts. We'll keep the method that is selected for wooden stairs utilizing string boards of 40 mm thickness, steps of 30 mm and newels of 90. And now we'll set the floor height at 2,800 mm. Now we need to complete the flight details. We'll select a straight flight and set the left side length to 2,000 mm and the width is 900. Now let's click on the plus sign to add a second flight. The left length is 2,500 mm, the right length is calculated automatically. The width is also 900 millimeters. The rotation is to the right, which we would like to keep. The angle defaults to 90 degrees. This is correct for our stair. On the CAD drawing, we had an exit angle of 15 degrees. We set that same value here. We've now set all the necessary flight parameters and can click OK. StairDesigner has calculated the staircase using its internal wizard linked to a set of control values that you can see in the Properties menu. The key parameters are riser height, tread width, and the stair rule. Acceptable values are defined via the Tools menu Control Values window, and they reflect a safe and comfortable stair design. Any calculated values falling outside this range are shown in red. For example, if I now set the total riser number to 12, all values will be shown in red as they don't meet our control values. Let's put it back to 15. We're now going to add a landing step of 70 millimeters. In the Quick Design toolbar, we'll click on the Add a Landing icon and select Model 1 and set the length to 70. The software automatically calculates the width. Next we have the position parameter that allows us to position the landing step inside or outside the stairwell. In this case we'll select inside the stairwell as we would like to respect the overall flight dimension of 2,500. Click on OK to add this landing step. Let's now add some extra components to our stair. Again in the Quick Design toolbar, click on the Add a Stringboard icon. We want our stringboards to be on the left and the right side of the stair, so we'll select all of them. We won't change the stringboard parameters below, which are sourced from our manufacturing method. We don't need any changes in this case. Click on OK, and we can see that the stringboards have been added to the stair. Now let's add newel posts. Instead of using the toolbar, we'll use the right-click menu to add them. We want the newels on the right side of the stair. Select the first newel post on the right side using the predefined point for the flight start. The newel is added and its parameters become available. As we're continuing to follow our manufacturing method, we won't change these values. Click on Apply and then we'll move on to the corner newel post. And finally, we'll add the newel post at the end by selecting the last point on the landing step and click on OK. The newels are positioned as we want them. The final component we'd like to add is the handrail. Right-click and select Add a Handrail. Select all the handrails on the right side and they will be shown in green in our 2D window. Our basic stair design is now in place. Next we're going to add the well hole to check our headroom space. Our CAD drawing shows a blue line at 1,600 millimeters from the back of the stair. This is where the well hole stops. Otherwise it has the same shape as the stairwell. We'll go now to the Modify menu and select Well Hole. A pop-up screen will appear where we will have to set the details. The length of the second flight automatically defines the length and is in line with our requirements. The width is set to 900. We can keep this for now as it will form the basis of our actual well hole, which we'll complete soon. The floor thickness is set to 300 millimeters, which we'd like to keep. Click OK and the well hole is added on top of the stair in green. In the Properties menu, we can access its parameters. Click on the Edit button and the well hole is now in edit mode. If we hover over the left side, we can see that the length is 900 millimeters. We need 1600mm, so we'll select the lower left point and change the Y value in the coordinate values from 1100 to 400, as we need to move that point 700mm down. Now double click on the diagonal line to add a point and position this on the other side of the first flight. We now need to set the well hole back to the corner of the stair. Double click on the right line again and position the new point at the corner. If your values line up with the grid spacing, you can set them by dragging. Otherwise, use the coordinate system to position them accurately. Double click on the screen outside the stair volume and the software will exit the editing mode. In the properties menu under headroom control, you can read the headroom height as 2126mm, which complies with our control value, which has been set to 2000. A value below 2000mm would show in red. Let's take a first look at our project in 3D by clicking on the 3D icon. Our manufacturing method defined oak as the wood type for all parts. Actually, we would like to use a combination of oak with some parts painted white instead. To make this change, go to the Properties menu and click on the Material Styles drop-down list. We'll select Cottage, which is a sub-method preset with the materials we need. The complete stair instantly changes to our specifications. You can create as many styles as you wish across any combination of wood types and other materials, or of course manually change each part in turn. Let's now change some component details. The 3D window of StairDesigner is an active window where we can select components and access their parameters. Any change will update our design immediately. Let's make a change to the corner newel post. The selected part turns green on screen and the parameters become available in the Properties menu. Go to the base height and set the from the floor value to 0. The newel post has now been extended to the floor. Select the right stringboard of the first flight now and set its type to straight. Do the same with the handrail. We want to change the winding of the steps now. This is managed in the 2D editing window. In order to see both windows, right-click on the 3D tab and select New Vertical Tab Group. We now have a split screen and can switch between the two by clicking inside each window or using the spacebar. So, inside the 2D window, let's make the first 5 steps straight. Select step number 5, right-click and select Straight Step. Step 5 and all previous steps are set to straight. The 3D render is updated in real time too. Let's now change the aesthetic shape of the right stringboard and create a larger base. In the 2D screen, select the Display Stringboards icon. We can select the stringboard in the drop-down menu or double-click on the stringboard in the overview. We are now in the editing mode for that stringboard. Notice that the width is not enough to cover all the steps. We'll change the width value in the Properties menu from 280 to 320mm. The stringboard is updated and covers all the steps now. Double-click on the stringboard to enter editing mode again. Double-click on the lower part of the stringboard to add a point. Select the lower point and drag it to the left to enlarge the base. Select the line between these points. Select the lower working point and move it to a position directly above the lower point. Select the top point and move its working point to get closer to the curve we want. Right-click on the top point and select Smooth Vertex. To correct the tangent of the curve, select the right tangent as the left side needs to stay straight. We have now finalized our stair design. In the background, all manufacturing details have been dynamically updated with every change we've made. Let's have a look at the different output options. First of all, when we're in the 3D view, click on the Print Preview icon to generate a 3D view document for your customer. Return to the 2D view and click the Print Preview icon again. A pop-up screen allows us to select the different components for inclusion in our workshop document. We'll select all components. The first page of this document shows the top view of the project with the main measurements and parameters. This is followed by the different components, so the steps, each individually per page, followed by the developed stringboard sides, left and right, the individual stringboards, the developed handrail view, individual handrails, the newels with details of each face, an overview of the banisters, the cutting list detailing the net dimensions, wood type and required material volume, and finally a materials and cost report for all components, so the materials used, the volume, weight and price. As well as this document, StairDesigner offers the possibility to use one-to-one size templates for manual production. Go to the File menu and click on Template Preview. Here let's select the stringboards and click OK. StairDesigner now shows the templates according to your settings and will automatically define the length of the template depending on each part. You can then generate a PDF file to later print the full-size templates, either yourself or outsource to a printers. You can also define any large format printer for direct printing. We have the 2D DXF plan that outputs the top view of your stair and the developed parts. You can also export your stair project in 3D DXF or 3DS for use in external software such as SketchUp. The 3DS adds in the different textures for use by an external rendering solution or to add the stairs into a general view of the customer's full project. Finally, StairDesigner has a full set of post-processors providing the technical files to run your CNC machine. Native file format output is available for a range of popular branded CNCs including BSC, Holzer, Felder, SCM and Homag. There is also an industry standard DXF post-processor compatible with virtually all other types of CNC. This video took a quick look at some of the key design features available in StairDesigner. These and many other capabilities are detailed in our website resources. We hope this has shown you how fast the design process is, with instant access to manufacturing output and 3D renders that are dynamically updated as you work on your project. Thanks very much for watching.